10.3, displaying data. This was the second part in sort of a two-section series, if you will. And we were in the middle of our example where we were creating a trend line based on a scatter plot. And we had written an equation. Our equation so far looked like that. And I said, please, please hold tight. This equation is not complete. If on a test or on a homework, all you write down is what we wrote down here, you're missing some really important features to make this equation usable. There's two things in particular that you're missing. You're missing what this equation gives you. So you plug in a number, what information comes out of this equation. So if you take a look, we let our horizontal axis be x. And we let our vertical axis be y. Right? I used x and y in my equation, so I'm going to label them x and y. Well, the way that functions work is that you plug in a value for x and it spits out a function for y, right? So if I plug something in for x and it spits out an answer for y, what types of values are y values in this context? What are the y values? What is the 76? What is the 66? They're heights. They're the vertical jumping heights, right? The y values here are jumping heights. In what units? Inches. So over here, we want to say that this is inches. At the very minimum, it has to say inches. Minimum. If you want to be more specific, it's the vertical jump heights. But the inches is absolutely critical. The more descriptive part of that is optional. Here's the other thing. I need to know what in the world I plug in. Because right now, if I give you, we plug in years, I get that. But if I give you the year 2010, was 10 on my graph? 2010 wasn't on my graph. I only had data go up to 2008, right? So if I want to know, well, what was the average or, what was my expected vertical jump height in 2010, what number are you going to plug in for x? Somebody said 10, and you're right. Why would you plug in 10 as opposed to, say, 2010? Or how would you know which one you should plug in?
Because it's after 2000.
Right. Over here on your graph, down here, remember we let the y-axis be the year 2000? Do you guys remember that? And I told you that's really, really important. Because if the y-axis were the year 0, this whole graph would look just like it is, but it would be shifted very, very far to the right-hand side. Are you with me? Which would mean that this line would extend way below the graph, right, or the x-axis, and my y-intercept would be different. The slopes would be the same, but my y-intercept would be very, very different. The way that x is determined really has to do with this particular y-intercept. This y-intercept should be the jump height in a specific year. What year is that the height in? Well, according to my graph, the year 2000. Because that's what my y-axis represented. It was the year 2000. So I have to actually include that information for this equation to be useful for any purposes. I have to say that x is years since 2000. Without that, there's nothing for the person who is reading this or wanting to use it to know that I'm supposed to plug in 10 instead of 2010 or something else entirely for my x value. Does that make sense? Yeah? So in particular, now that we know that, we can do part C, which is to use our equation to predict the jumping height this year. What year is it? 2019. So according to the information that I just labeled in my equation, what number am I plugging in? I'm plugging in 19. So this is y equals, I don't even know what I had because I've got a different, 5/3 x plus 59. So 5/3 times 19 plus 59. And I don't have this answer because the year was not 2019 when I wrote my original information down for this problem. It was 2016. So somebody tell me, what is 5/3 times 19 plus 59? Or, well, I need to know what that one is. But whatever yours is will end up being close. So use your equation. Julie, can you get me the one for my equation? Usually I have a calculator up here. One of my bag's missing right now. .7 if I round inches. And it's inches, right? That's the output of the height in inches. Okay, no matter what your equation really exactly looked like, whether the slope was 5/3 or whether it was 2 or whether it was 4/3 or some variation of that, or whether your 59 was 59 at the end or 58.5 or 57 or 61, whatever it is, your value here should still be in the ballpark of 90. Is it? A little high, a little low, but is it pretty close? It should be. If you're getting an answer of like 115, we got a problem. Does anybody's answers look weird at this point? Yes, Elizabeth.
Okay. Where, I know this is kind of a silly question, but what is B? I know that you said.
B is the y-intercept. It's the location where it crossed the y-axis. So on my graph, it looked like it was about 59, where it crossed the y-axis.
Mm-hmm.
Yours might not look like 59, but it should look, roughly pretty close.
Okay, thank you.
You bet. Okay, any other questions on this one? Okay. Okay, finishing this section up then. We talked about association last time. In fact, let me go back over to it. We talked about this particular graph and making a decision about whether or not it had a positive or a negative association. Do you remember what we said about this graph? I didn't write it on my screen. It was a positive association. Emily, do you have a remembrance of why we decided that? Yeah, it was moving uphill. It's exactly right. The slope in particular is a positive slope, right? So as x increases, y increases. That's a positive association, right? There comes a point in a lot of things where there's not necessarily positive association. If you're studying really, really late at night, the number of hours you're studying is not necessarily increasing your grade on a test. Yeah? There comes a point when there's no longer a positive association. It's just flatlined, or maybe even going downhill because now you're losing your sleep. So not everything has a positive association. Increasing x does not always increase y. From the standpoint of specific equations, we can also look at that too. So if we're looking at these three trend lines, what can we say is the association represented by each one? So on part A, do you think that this is a positive, a negative, or no association? It's negative. And how did you decide, Julie? Because there's a negative slope. So if that's what we're looking for, what kind of association is part B? It's positive association because there's a positive slope. What's going on C? Okay, so I think you mean horizontal. Is that what you mean? Yeah, you're right. It's a horizontal line, so it looks like this. So a horizontal line would be said to have no association. Or you could say none, something like that, no or none. There is no association here because increasing x, right, if I move from here to here, has absolutely no bearing on what y is doing. It's staying constant regardless. Any questions on those? All right.